Welcome to Pixel Perfect is Dead. Long live to adaptive and accessible iOS apps. Yeah, my name is Dani Devesa, and yeah, my pronouns he, him. I'm a white male, short brown beard, wearing brown flat cap, and my finest blue shirt and waistcoat or vest, depending on your country. And I'm speaking to you from London, but I'm originally from Spain, if you're wondering where this thick accent is coming from. And apologies to the interpreters beforehand. I love developing iOS apps. I love making them accessible, and that brought me to writing a book called "Developing Accessible iOS Apps" a few years ago. And I used to be quite active at sharing tips on how to make apps more accessible with the hashtag 365 days iOS accessibility. So today I wanted to show you first, tell you a bit the history of adaptive development in iOS, because I think it's fun. I think it's good to see where we come from. Hope you enjoyed that part. And then I wanted to show you actually what can we do to make iOS apps more adaptive and therefore accessible. And in the end, we'll just wrap it up, just explaining why I think it's important. So the story. And it started in 2007 when Steve Jobs came out on stage to present the iPhone. In the slides, there is a drawing of Steve Jobs holding up the iPhone. And it all started with a 320 by 480 pixel canvas. And I wanted to mention these numbers because at the beginning, one of the benefits of developing apps for the iPhone was the lack of fragmentation. So if you were developing apps back then, those numbers, like, you know them really well. You'd hardcode them very often. If you wanted to center something, you would probably do 320/2. You got it. 2008, an iPhone OS 2 was presented. Yeah, back then was called iPhone OS 2, iPhone OS instead of iOS. Let the games begin because the SDK was also introduced. So for the first time, we could develop apps for the iPhone. But sadly, the iPhone was not a very accessible device back then. Neither was iPhone OS. So yeah, you could develop apps, but you couldn't do much about making them accessible. Back then, for example, if you want to do an app that responded, for example, to rotation, you'd use something called auto-resizing mask. Is a concept that came from macOS. And it was based on something called springs and struts that you could deactivate or activate in order to define how a subview should behave depending on how the superview changed in size or position. So that's how it started. And this is still available, actually, and is sometimes the worst nightmare of an iOS developer. If your UI is not showing up as you expect, it's probably because some of these auto-resizing masks are coming into action. 2009 is a very important year because the iPhone 3GS was presented, but more importantly, Phil Schiller back then came on stage at the WWDC 2009 keynote to present accessibility for iOS. So he showed during a few seconds in that keynote the new accessibility settings where VoiceOver was introduced, Zoom, the magnifier in iOS, was introduced as well, and some other settings. So it was off to a good start. But then in 2010, Steve just presented the first generation iPad. So suddenly we have a bit of fragmentation, right? Like we have two categories of devices, a phone and a tablet. But mostly people would just develop different UIs for one platform or the other. But then that same year, the iPhone 4 was released. And it came with a higher density screen called Retina display that had basically double the density of the previous iPhones. But we will still work with those 320 by 480 numbers. The trick was that Apple introduced the concept of points. And in the previous iPhones, a point was a pixel, and in the new ones, a point was 2 pixels. But then 2012, an iPhone 5 is released. The screen is larger, different aspect ratio as well. So in the slide, there is a drawing of how the YouTube app looked when the iPhone 5S was released, with black bars on the top of the bottom, because the app would display with the previous aspect ratio for the iPhone, the original iPhone. And you had to do some work to make your app work for this new aspect ratio. So we're starting to have some fragmentation, right? With different screen densities, device categories, aspect ratios, sizes. And that's when, that same year, Apple introduced auto layout in iOS 6. And there's two main ways of developing UIs for iOS. UIKit and SwiftUI are the native UI frameworks. SwiftUI was introduced many years later. But if you are developing today apps in UIKit, you a lot of times still use the concept of constraints and auto layout. In the slides, I'm showing just a random sample of code of how it looked, but basically the idea is you can define constraints or relations between views. And some tricks that I can provide straight away is it's important to avoid constant heights and widths, because that means that your layout would not be flexible. And if you need to use larger font sizes, for example, it can break. And also, you have the concept of leading and left constraints and trailing and right constraints. And this is important because you may think, what's the difference? So left is always left, right is always right. But leading can be left or right depending on if you're using a left to right or right to left language. So UIKit would use the right one for you. That's pretty neat. In 2013, iOS 7 was released. It was a major UI revolution. If you remember, we went from skeuomorphism, or the concept of applying textures and concepts of the real life that reminded us to real objects in the UIs, to a completely flat design, flat colors. It was a big change, and for a lot of people, it was also a step back in terms of accessibility, because it had lots of transparencies, translucencies, animations. Sometimes the contrast ratio for colors, for the color palette, was not the best. The font used to be quite thin as well, but not all was bad. That year, also 2013, Apple introduced the concept of dynamic type, which is one of my favorite features in iOS, and is the possibility for the user to select the font size they want in the system and the apps installed in their devices. There's a sample of code in the slide showing how, instead of setting a font based on a size, on a specific size, you can set a font set on a text style. In this case, body. There were others like large text, title 1, title 2, headline, and so on. And then the system would decide what the right font size is for that style. And 2014, iOS 8, one year later, I think Apple probably recognized some of these issues with iOS 7, and they introduced a bunch of settings that could let you do things like have bolder text or larger text sizes, as we've seen, or the buttons in iOS 7 you just use like they look like labels with a color. So you have the possibility to add button shapes, reduce the transparency, increase the contrast, and so on. Like there were a bunch of new settings. And as well as those settings that provide flags for the developers to be able to check if the users opted into any of the settings. There were notifications to let the developer know if, while the app was running, any of those settings changed. It's important to know as well that if you use native components, most of the times these things worked automatically for you. But if you're developing custom components, you can still check these flags or notifications to act accordingly. So yeah, that was 10 years ago, but let's stop here because right now I think we have all the necessary context and the idea to know what can we do to make apps that are more adaptive and therefore more accessible. So I'm going to show you three things. One is um, we're going to talk a bit more about this display and text size settings, those customizations that the user can do. We'll focus on dynamic type because I think it's a very important one. And at the end, we'll talk about Swift UI, this new framework to develop iOS interfaces. So display and text size settings. I thought of showing first an example for one that is called increased contrast in settings. And if you're a developer, you'll know it as darker system colors. In the slide, I'm showing the stock app that shows some prices in red when they're going down, green when they're going up. And there's an example where there's white text on green background, and it has a contrast of 2.2 to 1, so it fails. But if you select increased contrast, you get one of 7.3 to 1, so it passes. And I'm now showing some examples, like code snippets, of a function that could check this flag that I mentioned. It's called UI accessibility dot is darker system colors enabled. And in that case, you can assign a darker green to that background, or otherwise you can assign the default green. And also I'm showing how you can add an observer to a notification center, and then you can call that same update colors function when that system setting changes. So in iOS, it's super cool because you can provide actually, well, first you can use the default system colors, and they will work with this setting automatically for you, and they will also work automatically when you use dark or light modes. So these colors, I'm showing in the slide an example where you have, for example, system red, and there's 4 variants. 2 that are called accessible for light and dark, and 2 that are the default ones for light and dark. And next to it, I'm showing an example of a part of Xcode where you can create your own colors. And exactly like the system colors, you can provide different variants for both dark and light mode, and default and increased contrast. And for many iOS developers that may be joining, yeah, just a quick mention that color contrast is not just about the ratio, but also about the text size. So in the slides, I'm showing how white on black works almost all the times, 21 to 1. If you have a light gray over black that has a contrast of 4.5 to 1, at small sizes, it starts to be very difficult to read. And then 2.9 to 1, like a darker gray to black, it's really difficult to read in any text size. Another example of these settings is one called Smart Inverted Colors. So iOS also came with a setting that let you just invert the colors of your screen. And that was useful, for example, if an app just supported night mode, or had like a white background, and maybe you are a photosensitive person and you find difficult to stare such a bright screen, so you could just invert the colors and then it becomes kind of dark. But it came at the expense of inverting the images as well, so they didn't look very well. So there's a property called accessibility ignores invert colors that you can apply to media, for example. And if you do that, everything will invert, but like images and videos that you decide not to invert, for example. And yeah, also dark and light modes. So I'm showing an example in the slide in a drawing of common accessibility logo of the stickman inside a circle, but it's dressed as Darth Vader, and it's some text around that says, "I find your lack of accessibility disturbing." So yeah, I think it's super important to implement both dark and light modes. And these are 3 of the examples, but I wanted to also mention, for example, reduce motion. And that's one very important. If you have animations in your app, consider this setting, for example. and make sure that the animations doesn't like stop when the user decides to have reduced motion. Yeah, and let's talk about dynamic type now. So in the slides, I'm showing that dynamic type is composed of 11 styles. We talked about it, large title, title 1, title 2, headline, body, caption, so on. And the system provides 12 sizes for the user to choose from. 7 are the default text sizes, and 5 are accessibility text sizes that you can enable as well. So it goes from extra small to large, which is the default, to extra, extra, extra large, and then you have accessibility extra, extra, extra large. And I'm showing now a graph, size points in the y-axis and dynamic type sizes in the x-axis, because I think it's very interesting to see how Apple treats those text styles. And the thing is that as you increase text sizes, they don't grow linearly or proportionally, but the smaller text sizes tend to increase more rapidly than the large ones, with the idea of styles that are already large don't need to grow as much. And then you can leave space for the small styles to become very big, making all the styles easier to read. But they always keep some differences, so you can still appreciate the hierarchy between these text styles. And to know how to implement well dynamic type is also very important to understand the concept of size classes. In the web world, maybe you know them as breakpoints. So the idea is instead of checking for a specific size in order to change your or adapt your layout, you have this concept of size classes, and you have horizontal size class, vertical size class, and it can be compact or regular. And in the screen, I'm showing how, for example, for an iPad, is always regular, both horizontal and vertical, depending on if it's portrait or landscape. For an iPhone, though, it's regular for the vertical one and compact for the horizontal one. But if you rotate it to landscape, both become compact. But that's not all, because in iPad you also have split screen. So if you have 2/3 and 1/3 for split screen, the smaller one is compact for the horizontal size, and the app that is taking more space in the screen has a regular horizontal text size, horizontal size. Just so you get the idea. The idea is you don't really need to care about when it's one or the other. It's just how my app looks if the horizontal size class is regular and the vertical one is regular or compact. So if Apple decides to have like new ways of displaying apps in the iPad or new screen sizes or form factors, your app should just adapt well. And one thing that is very important to understand when you develop apps with these auto layout constraints that we talked about is that you have the possibility to activate or deactivate them. In the screen, I'm showing an example of a cell that is meant to be displayed in a table view that has an image and next to it some text. And I'm showing how also another example with larger text. And in that case, I'm showing the image first, and then underneath the image, it becomes the text. And I'm showing how some of the constraints are common. And then you can have two other sets of constraints. Ones that complete the definition for the constraints for the default text size, for example. An alternative set of constraints that you're going to replace by that default one when you have larger text sizes. With the idea of you can tweak the layout if the user decides to use a large text size. Because if we have an image and next to it some text, then and you make the text large, then the text cannot use the whole width of the screen, and it becomes very difficult to read. I'm showing some code in the screen as well to see how you can basically um, check for these for the dynamic type sizes that the user decided to configure, and how you can activate or deactivate these sets of constraints to show one variant or the other variant of the UI. And it also helps with portrait and landscape modes as well. I think like iOS developers should make a bigger effort in supporting apps in landscape mode, in my opinion. And um, that technique of deactivating and activating constraints to have different variants of your layout can help with that. But this is much easier. You can also use something called stacks or stack views in iOS. And a stack view can configure it with horizontal axis or vertical axis. And there's a neat trick where you can check the size class or the dynamic type size. And based on that, flip the axis of the stack view. In the screen, I'm showing an example where it's pretty similar to the previous one, where there is a stack view represented in blue where I'm displaying an image and some text next to it because the axes are horizontal. But when the user decides to use a larger text size, I flip the axis to vertical so the image comes first and underneath the image, the text. So you have more space for the text. And then you can get into very specific things as well. Maybe you have thought sometimes, what is the ideal width of a line of text for it to be readable? And iOS has you covered as well. And there's a constraint called readable content guide. So you can assign that to your piece of text. And if you've configured the default text size, then and you are in an iPad that is in landscape, for example, the text won't take the whole width of the screen because if the lines are too long, then it becomes very difficult to read. It will leave some margins in both sides. Now, if you don't configure this readable content guide and you increase the size to the maximum accessibility text size, you'd still have those margins, right? And for large text sizes, actually, you prefer to have the text to take more of the screen. But if you configure this readable content guide, iOS does that automatically for you. So it just takes the ideal space or the ideal width for the text line. And similarly, if you have some text that goes one on top of the other, you may think, what's the ideal space in between them? If you have a fixed space, it might look well with the default text sizes, but then for large text sizes, it might not be enough, and text might be too close together. But you can actually specify the system spacing between those lines of text, and iOS will just configure the ideal spacing in between those two pieces of text, depending on the dynamic type setting that the user has configured. And one thing to consider as well is if you have multiple columns, it's a good idea to switch from two columns, for example, to one, if the user decides to have a large text size or an accessibility text size. With the same idea, so the text can go from side to side of the screen. So in the slides, I'm showing an example of the weather app and how sometimes it shows information like UV index or sunset or wind or rainfall in squares in the screen into columns. But actually, if you configure the text size to be the largest one, it goes to one column and it's much easier to consume that information. And then You can make that so the text grows if the user decides to configure a larger text size, but you can also make it so the images grow if the user configures an accessibility text size. So there's a property called adjust image size for accessibility content size category. And if you set that to true, it will automatically scale the image for you when the user decides to use a larger text size. Now, it's important to know as well that it needs to be an image where you keep the vector data. Otherwise, if you use a PNG, it's going to look a bit blurry. And that's provided in iOS, like the format is PDF. It's a bit weird, but yeah, that's how it is. And there's an exception to scaling your layout for large text sizes, and that's with navigation bars, tab bars, toolbars, any sticky bars on top of the bottom of the screen. And the idea is that if you make those bigger, they take too much real estate from the screen, leaving very little space for content. And you may think like, then how can I, as a user, like see what's in those bars? And I'm showing an example in the slide is the Apple TV app. And basically, if you tap and hold your finger in the navigation bar in the title, it will show a large square in the middle of the screen with large text. In this case, Watch Now, which is the title. So it's called large content preview. If the user touches one of the elements in the tab bar, in this case, the Watch Now tab, same thing. There's a large text, a large square in the middle of the screen with a large icon, in this case, a play inside a circle, and the title, Watch Now. And then another thing to consider as well is now in iPhone as well, you have the notch in iPhone 10 and forward, and dynamic island came in, and the home indicator. So there's the concept of safe areas and things where you should make sure that you basically leave empty and make sure that your layout doesn't grow beyond that safe area. So yeah, supporting dynamic type. A lot of developers think that is very difficult. This is kind of my playbook. Use predefined styles if you can, and that will make the heavy lifting for you. Map your styles to predefined ones if you have a custom font. So using a custom font is not an excuse for not implementing dynamic type. You can do it as well. Think if your layout needs to be tweaked for larger text sizes. And we've seen some things you can do. You can swap a horizontal stack for a vertical stack. You can display content in one column instead of multiple columns. You can allow for more lines when the text size is large, so the content you display to the user is the same regardless of the text size. Make sure that you're supporting large content preview. And yeah, make sure that you may need a scroll view as well. Like just make sure that if the text size is the largest one, the content still fits on the screen, or you can scroll through it. So SwiftUI. SwiftUI is the kind of the modern way of developing layouts or in iOS, and is what most new apps probably would use. And everything I show you so far was about UIKit. So what now? Should we forget about everything I just said? And in the slide, I'm showing Will Smith in Men in Black, showing that device that he uses to wipe the memory of everyone in front of him. And some text and an arrow pointing to it saying, look here. But not really, because SwiftUI actually has the same concept, applies most of these concepts as well, and even supports them better out of the box. In the slide, I'm showing an example that is one of my favorite SwiftUI features, and is the possibility of previewing your SwiftUI interface. And Xcode has some options to show you how your UI looks in dark and light mode, for example, and also how your UI looks in all the possible text sizes that the user can configure. So is a really easy way to make sure that your app supports in this case, dynamic type or dark and light modes. And I'm showing some code in the slides now where I'm doing something similar to that trick where you could flip the axis of the stack views. You can do a very similar thing in SwiftUI. Instead of those flags and notifications, you have the concept of environment variables. So in this case, I'm checking if the horizontal size class is compact or regular, and you can do the same with dynamic type sizes. And provide ones, like in this case, it's called a V stack in SwiftUI, or an H stack, depending on the dynamic type size. And for lots of the other settings, similar thing, you have other environment variables for legibility weight, invert colors, increase contrast, reduce transparency, or reduce motion. So I just want to show a quick thing, if possible. Let's see. I'm going to share. Okay, hopefully you should be able to see my iPhone. And I want to show you how you can configure something that is called accessibility shortcuts. And that way, it's easy for you to switch to any of those settings that I talked about. I think the more people know about those settings, the more people would use them. So in my case, for example, I love bold text. I think everything just looks better with bold text. And it's easier for you to test as well if you're developing. So if you go to settings and you scroll down to accessibility, you scroll to the bottom, there's something called accessibility shortcut. And now that is going to show you a list of lots of assistive technologies and accessibility settings that are available in iOS. So you can select a few of them, like VoiceOver, and that would give you a quick way of enabling VoiceOver. But you can also use increase contrast, for example, or reduce motion, reduce transparency, smart invert, whatever you want. And while we are here, if you scroll to a bit to the top as well, there's controls. Go back to settings. You have control center. And I would totally recommend you to add accessibility shortcuts and text size. Okay, so now if I triple click the side button in my iPhone, the one that you use to trigger Siri, it's going to show you a list of all those accessibility shortcuts that we enabled. So I can choose increase contrast, for example. And then the good thing about adding those in Control Center is that you can now find them here as well in Control Center. So we can see, for example, there's open the weather app, for example. And you can see how if I increase the text size, oh, not connected to the internet. Anyway, but you can, I guess you can appreciate how the text became much bigger, much larger. Oh yeah, and I forgot as well, if you go to settings and go to display and sorry, accessibility, display and text size, and larger text. In this case, there's a way of enabling these larger accessibility text sizes. So now I can switch to even larger text sizes. So yeah, if we go back to settings, here is an easy way to see how you can quickly see how your UI changes depending on text size in this case, or as we've seen, again, smart invert. And now everything is inverted. So yeah, to wrap it up, why is all this important? And you may have heard about this story of the US Air Force in the 40s, and they were having a massive problem where lots of days they were planes, like pilots were crashing their planes, and they were trying to figure out why it was, and they couldn't. And one of the ideas they had is those cockpits for those planes were designed in the 20s, almost 30s. And what they did was to measure a bunch of pilots, hundreds of them, take the average measurements and create a cockpit for the average pilot. So they figured, well, it's been a bit of time, so maybe those measures are outdated. Why don't we measure pilots again and design a cockpit for today's average pilot? But what they realized after measuring tons and tons of pilots is that those measurements wouldn't fit any of the specific pilots. So by trying to design a cockpit for everyone or for the average pilot, they were designing a cockpit for no one. In the end, they decided to create adjustable seats that today you can, like that technology you can find in cars, for example, adjustable straps for the helmets, adjustable pedals. So basically, you could configure your cockpit for your size, and that solved the problem. From there, the pilots thrived. So it's a good example how when the tools can be adapted to our bodies, our abilities, our needs, we thrive as humans. So when someone says, why should we create adaptive apps? I just tell them, do you want your users to fly or to crash? And in the slide, I'm showing a dial that is turning accessibility all the way up to the maximum, in this case, number 11. So yeah, that was all. Thank you very much. In the slide, that's all, folks. Cartoon from the Looney Tunes. It was a pleasure, and then looking forward to your questions.
Yeah, great. Thank you, Danny. We've got some good questions here that came in, so I'll just start reading them off and
Awesome.
throw them your way. We've got a question from Keith who asks, are there any tools built into Xcode that can make designing for accessibility easier? Or are there any external tools that you might recommend?
For designing, yeah, it's a good question. So Swift UI, for example, you write the code and immediately see the preview of how the UI would look with that code. And as I've shown, you can see how that UI also adapts to large text sizes or things like dark and light mode, right? But you can also inspect the elements in the screen to see what accessibility labels they're going to expose to the user, or accessibility value, or how things are grouped. So it's kind of a good way of making sure that your app is accessible as you develop. Xcode also has a tool called Accessibility Inspector that for some reason not many people know about. So you go to Xcode in the top menu, I think, open developer menu, developer tools, and then Accessibility Inspector. And that has great things like you can run your app in the simulator or device. You can enable or disable some of these settings that we talked about, like increase contrast, reduce motion, to see how your app works in the simulator. You can also run an automated audit in your app that checks for things like labels that may not be adapting to dynamic type sizes, or color contrast failures, or elements that don't have a label. So that's pretty useful as well. And again, you can also inspect or preview how VoiceOver is going to announce those things to the user. So there's a lot of things built into Xcode. And the accessibility inspector has also a color contrast calculator that is quite handy as well.
Great, thank you. Let's take another question here. I've got a question from Josie saying, how many of the variations for text sizes, etc., do you recommend a design team mock up ahead of time? It seems like it could be a lot of variations to communicate to the dev team, but worth it to provide the accessible experience.
Yeah, that's why the title of the talk of not trying to be pixel perfect and not to control how your app is going to look in every single scenario. So what I usually recommend is design for a small screen size. In the case of iOS, you could design for an iPhone SE. That's probably the smaller screen size available. And then mock up how it looks for the default text size and the largest one. because then is where you're going to see how your UI may not work for larger text sizes and how you need to adapt for yeah, like one size or the other.
Mhm.
Then if you want to go the extra mile, once it's developed, you can use this shortcut that I showed you to see how your app adapts in different text sizes. And you may decide that it's better to switch from one type of layout to the other at a specific text size, like extra large, instead of waiting for accessibility text sizes, for example. So that's another thing I like to do. And yeah, just try not to control how your app looks in every single device and variant.
Great. Okay, another question here from Rose, saying, in audits, we have been flagged for not passing color contrast, but my team says we are using system gray colors. How do you handle this or avoid this?
Yeah, that's something I forgot to mention as well, that so for example, for increased contrast, like color contrast should, in my opinion, pass regardless of the user enabling this setting or not. Because users may not know about that setting, for example. And then increased contrast should be a way for providing even higher contrast. But it's true that sometimes, depending on how you use the system colors, color contrast may not pass. And I think another good use case for this is sometimes you just cannot convince your team to increase the contrast of the colors because uh, they don't like how it looks or whatever. In that case, you should at least be able to provide a higher contrast color for the increased contrast setting. But yeah, in my opinion, even if the setting is off, color contrast should pass. So there's darker grays in this case that you can use from the system palette of colors. I would review that.
Good. Another question then that Keith added on is related was just to those system settings. Is the default body text size big enough? I'd incorrectly expected that everyone that needed a larger text size would adjust for it in system settings.
Um, yeah, I think it might be big enough. Some stats I've seen is that around 30% of users change the default text size, if I remember correctly. From that 30%, half of them choose actually a smaller text size, so you can have more content in the screen, and half of them choose a larger text size. So I'd assume that, I mean, it can also be that most users don't know about this setting, but 30% is a huge number, I think, of people changing the text size, the default text size. So yeah, I think it might be, and if not, you can always yeah, exactly, use that setting to increase the text size.
Mhm. Yep. All right, another question we've got here from Christian is, how do these options translate to cross-platform development? And I think that came in near the end when you were talking about Swift UI things.
Yes, for Swift UI and UIKit, they should work the same. Then exactly, you can use Swift UI to develop apps for the Mac, for example, and a lot of these settings exist in the Mac as well. So if you implement an app that works with the increased contrast setting, it should work across platform. So iPadOS, iOS, Mac, Apple Watch. Like the great thing is, I think Apple has done a great job of creating like a very consistent set of APIs and tools that work well across devices. So now, for example, if you get one of those cheap Vision OS, Vision Pro devices, they come with a ton of accessibility settings, some new and some that they're leveraging from years of implementing accessibility settings in Apple's devices. So the first iPhone, as we mentioned, was not very accessible, but now Vision Pros come with VoiceOver, switch control, like everything, increased contrast. So yeah, it tends to work really well across devices and platforms.
Great. All right. I'm going to ask one more question here. And that is how do you manage, how to manage to test to agree on what is done? So agreement between development, testing, PMs, and designers.
Yeah, that's an excellent question as well. This needs to be part of the whole process. So I think PMs, for example, need to account for a bit of extra time to make things accessible. Designers need to take it into account when they're doing the designs. Like we've mentioned, maybe it's a good idea to have this extra mock-up for large text sizes, for example, to make sure that the layout is going to work in every scenario. Developers are going to maybe need a bit of extra time to to make these variants and to test them. QAs will need to make sure that it works as well. So is a good one. I think it should always be the case that, yeah, in my opinion, you test, for example, at least for VoiceOver. So when things tend to work well for VoiceOver, they tend to work well for keyboard, switch control, voice control. Not always the case, but it tends to be like that. Um, if if you use a color palette, as we mentioned, that works with light and dark mode, it's good to test it as well, but it's rare that it's going to break in the development process. And I think it's a very good idea to test with small screen sizes and large text sizes. And if it works in that case, I think it works for most cases.